I have already done the unboxing of the SunFounder Ultimate Sensor Kit and explained in detail which sensors and boards are included in this kit. We will use all these sensors one by one. I have already made a detailed video on the Arduino Uno R4 Minima board where I have explained the technical specifications, pin out how to add this board in the Arduino IDE and how to upload a program. Not just that, for a comprehensive explanation, I have also compared the Arduino Uno R4 Minima board with the Arduino Uno R3. So I would recommend watching my video on the Arduino Uno R4 Minima board. You can find a link in the description. Anyway, from this sensor kit, we are going to select number 1, Arduino Uno R4 Minima board. If you have the latest Arduino Uno R4 Minima board, that's great. If you don't have an Arduino Uno R4, you can also use an Arduino Uno R3 or an Arduino Nano. Number 2, a breadboard which allows you to use components without any soldering. Breadboard is one of the must-have tools for testing your prototype projects. Number 3, RGB LED module. You can use this in different projects. Let's say when the sensor value is normal, you can simply turn on the green LED. When the sensor value starts to increase, you can turn on the blue LED. And when the sensor value exceeds a threshold value, then you can turn on the red LED. You can also use it in security projects and for testing the output states. Number 4, a push button. A push button with Arduino allows beginners to create interactive projects like games or alarms, facilitating hands-on learning and improving coding skills by introducing elements of user input and control. Number 5, jumper wires. These are some male-to-male and male-to-female type jumper wires. With the help of these wires, we can interface different sensors and modules with Arduino. Number 6, a 9-volt battery to power up the Arduino. This is optional because in today's examples, we are only using RGB LEDs and a push button. So we can power up the Arduino Uno R4 board from a laptop or PC as well. This RGB LED module has a total of 4 pins clearly labeled as minus, R, G and B. On this RGB LED module, the cathode legs of the LEDs are connected together. Therefore, we will connect the negative pin with ground and the RGB pins are connected with the anode legs of the LEDs. So we will connect these 3 pins with the I/O pins of the Arduino. To control a common cathode RGB LED module, you can adjust the brightness and color by changing the voltage on the R, G and B pins. Each pin controls the intensity of its respective color, red, green or blue. By providing a variable voltage through pulse width modulation PWM on the Arduino's I/O pins, you can mix these colors and various intensities to create a wide range of colors. The common cathode minus pin, which is connected to the ground, acts as a shared ground for all 3 LEDs in the module. Remember, to protect the LED, it's important to use a current limiting resistor with each of the R, G and B pins. But this RGB LED module already has current limiting resistors, so there is no need to add any resistors. This push button module has a total of 3 pins, the signal pin, voltage pin and ground. These 2 modules are breadboard friendly and interfacing them with the Arduino Uno is quite easy. The design of these modules allow them to be easily inserted into a breadboard, facilitating a simple and quick connection without the need for soldering. This feature makes them ideal for prototyping and experimenting with different circuits and configurations. To connect the RGB LED module to the Arduino Uno, simply connect the minus pin to the Arduino ground, connect the R, G and B pins to the Arduino PWM pins 9, 10 and 11. Connect the signal pin to the Arduino I/O pin because the Arduino will detect the button press with the help of this pin. This allows the Arduino to read the state of the button. When the button is pressed, the state changes, which the Arduino can detect and use to trigger events or actions in your code. Next, connect the middle pin to the Arduino's 5-volt supply. This provides the necessary power to the button. Finally, connect the minus pin to the Arduino's ground. You can follow this circuit diagram. Although we have connected both the modules, but first we will start with the RGB LED module. I will run some basic programs on it, such as how to control these RGB LEDs individually and how to mix these LEDs to generate different colors. So let's go ahead and start with our first example. We need to properly define the pins. It's important to name them accurately so that anyone reading the program can immediately understand their purpose. As you can see, I have properly defined all the 3 pins of the RGB module. Anyone reading this program will immediately know that I have connected the red, green and blue LEDs to the Arduino's PWM pins 9, 10 and 11. You can also define these pins without using the constant keyword. However, there are certain advantages to using the constant keyword. For example, the constant keyword tells the compiler that the value of R pin is constant and should not change throughout the program. This means that once R pin is set to 9, it cannot be altered anywhere else in the code. This is particularly useful for pin assignments in Arduino and other controller boards, as the pin connections are typically fixed once the hardware setup is completed. By declaring R pin as a constant, it prevents accidental modification of this variable in the code. If any part of the program attempts to change the value of R pin, the compiler will generate an error. This helps in maintaining the integrity of the code, especially in larger or more complex programs. Using constant makes the code more readable and understandable. It clearly communicates to anyone reading the code that this variable represents a fixed value, in this case a pin number that should not change. This is helpful for both the original programmer and anyone else who might work with or modify the code in the future. After properly defining the pins, the next step is to inform the compiler about the roles of each pin, distinguishing which ones will function as inputs and which as outputs. This crucial step takes place in the setup function, a fundamental part of every Arduino program. The setup function is essentially where we lay down the groundwork, setting up the initial conditions and configurations for our Arduino project. It runs only once when the program starts, making it the perfect place to initialize pin modes. In our case, as the LED is an output device, we utilize the pin mode function to set it as output. This tells the Arduino that these pins will be used to control the LEDs. In Arduino programming, the loop function is one of the core aspects of any sketch. It runs continuously after the setup function has completed its initial run. This is where the main part of your code executes and is the heart of most Arduino programs. It's where the dynamic actions of your code take place, responding to sensor inputs, controlling LEDs, motors, and other components. To turn on or turn off any pin on the Arduino, we use the digital write function. It takes two arguments as the input, the pin and the state high or low. You can see I have turned off all the LEDs. Then there is a delay of 1 second. 1000 milliseconds are equal to 1 second. Then I'm turning on and turning off each LED with a 1 second delay. Let's go ahead and upload this program. In my previous tutorial on the Arduino Uno R4 Minima board, I have already explained how to install it in the Arduino IDE and how to upload a program. In a program like this, if you want to change the delay time, you will have to manually change the delay at all places, which can be quite annoying, especially if the code is lengthy. To easily change the delay time, we can define a separate variable and then use it in the delay function. To explain this point, I have slightly modified this program. You can see that I have defined a variable named myDelay, where I have stored the value 500. This represents the delay time in milliseconds. I have used the myDelay variable in the delay function throughout the entire program. Now, if I need to change the delay time, I can simply go to the top and change the value there. Let's go ahead and upload this code. Let's make it faster. I'm going to change the delay time to 100 milliseconds. Now let's try 50 milliseconds. Now the LEDs are blinking at a faster rate. Just by changing the delay time, you can generate cool patterns. Anyway, next we are going to generate different colors. As you know, RGB LEDs or red, green, blue light emitting diodes can emit light in three primary colors: red, green, and blue. These LEDs are widely used in various applications due to their ability to produce a broad spectrum of colors by adjusting the intensity of each primary color. In this example, I'm not going to control the light intensity, but I'm going to directly mix these primary colors. I modified the program a bit. I changed the delay time back to 1000 milliseconds. Now, if we go to the loop function, you can see I added these other instructions. There isn't anything complicated. I'm just turning on and turning off multiple LEDs at a time to generate different colors. To generate the yellow color, I'm simply turning on the red and green LEDs at the same time, then it stays on for 1 second and then turns off. Similarly, to generate the cyan color, I'm turning on the green and blue LEDs at the same time. To generate the magenta color, I'm turning on the red and blue LEDs, and for the white color, I'm turning on all the LEDs at the same time. Let's go ahead and upload the program. To avoid making this video too long, I will use the push button in my next video. So that's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.